start with question number 31, right? So what it is saying, question number 31 in trigonometry is like that: x is equal to h plus a cos theta, right? And y is equal to a plus a sin theta, a sin theta. Okay. So you have to prove that x minus h whole square is equal to plus y minus k whole square is equal to a square. Can you think of? This is to prove. Right? So what you can do, you bring this, you write it like this, that x minus h is equal to a cos theta, and you write here y minus k is equal to a sin theta, right? You write it like this, right? Now taking square both sides, now taking square both sides, right? Taking square both sides, so x minus h whole square is equal to a cos theta whole square, right? Similarly, y minus k whole square is equal to a sin theta whole square, right? It can be written as x minus h whole square is equal to a square cos square theta, and y minus k whole square is equal to a square sin square theta. Just wait for a while. Yeah, done. So this is the equation 1, this is the equation 2. Now on adding equation 1 and 2, on adding equation 1 and 2, so x minus h whole square plus y minus k whole square is equal to a square cos square theta plus a square sine square theta. Get it? On adding these two, we get like this. You take a square common with them, so we can write x minus h whole square plus y minus k whole square is equal to a square you have taken as a common. It becomes sine, it is cos square theta plus sine square theta. So what identity we know? We know that cos square theta identity is cos square theta plus sine square theta is equal to 1, right? So we can write here, so in this place we can write 1. So therefore your final answer will be x minus h whole square plus y minus k whole square is equal to a square. Getting? So this is hence proved. So this was question number 31. Right. Right. Should I rub this? We done this? So now question number 30. Right? What is that? X is equal to a sec theta plus b tan theta. B tan theta. Fine. And what is y is equal to a tan theta plus b sec theta. It is like this, right? So you have to prove that you have to prove that x square minus y square is equal to a square minus b square. A square minus b square. Right? So what do you do in that? Now, so how we will solve this? Every time same logic. Oh, good. Okay. X squared is equal to a squared sec squared theta plus b squared tan squared theta, right? And y squared is equal to b squared sec squared theta plus a squared tan squared theta. Get it? Now this is equation 1, this is equation 2, this is taking square both sides. Okay, square both sides, both sides. You can. So on subtracting, on subtracting, this is x square minus y square is equal to a square sec square theta minus b square sec square theta, right? No, this is a square sec square theta minus b square sec square theta, then minus b square, then b square tan square theta, minus a square tan square theta, right? So what we do, x square minus y square is equal to sec square theta. We have taken as a common, it becomes a square minus b square. Minus, you have taken, minus, you have taken tan square theta, then what will happen is totally miracle. No, when we are taking this plus, actually sign convention is like this. There will be minus. So we will put minus here. Here will be minus. So we put minus here, and here will be minus. So this will be plus. Yeah. So this will be. I was a bit confused. This will be in plus, right? When it is in plus, so we take plus here, and then we get, definitely we get b square minus a square, right? Now we take minus 1 as a common. Here we take minus 1 as common. Take minus 1 as common. So it will be x square minus y square. It becomes sec square theta bracket a square minus b square, right? It becomes, you have taken minus as a common, right? So there will be plus, sorry, there will be plus, but here will be minus tan square theta bracket a square minus b square, right? So this plus minus turns to minus, right? And then we get as a whole, that is x square, that we get x square minus y square is equal to a square minus y square. A square minus y square we have taken as a common, and we get sec square theta minus tan square theta. Get it? And this by identity, this is equal to 1, right? We know we know sec square theta is equal to 1 plus tan square theta, right? So sec square theta minus tan square theta is equal to 1. So we put here 1, so this will be multiplied by 1, so this turns to be, this whole turns to be 1. As a whole we get x square minus y square is equal to a square minus y square. Get it? So hence it is proved. I hope you understand. You done? Okay. Should I do this? Should I do this? Now, I hope remaining you can try to do. Come to question number 26. Remaining three are almost same. In the same manner you have to do that. Right. So come to question number 26. Question number 26. Okay. So can we start with the third part? So what is third part? That is tan A plus sin A, tan A plus sin A upon tan A minus sin A, right, is equal to what? is equal to sec A minus 1 upon sec A plus 1. Like this. This is that, no. This is upper one is plus, this is plus, this is minus, right? No. Now we will solve this question. So if I write LHS, LHS is equal to tan A plus sin A upon tan A minus sin A, right? So it can be written as sin upon sin theta, sin A upon cos A plus sin A upon sin A upon cos A minus sin A, right? This is we have. Now you take cos A as a common, so what you will get? You will get cos we have taken as a common LCM, so it is sin A plus sin A cos A upon we have taken sin A minus sin A, we have taken cos A again here as a common, so it is sin A cos A, right? This cos A is gone, and at last you get sin A you have taken as a common, and you get 1 plus cos A, 1 plus cos A upon sin A you have taken as a common, you get 1 minus cos A here. Get it? This sin A is gone. So now we will come it like this, that 1 plus 1 upon sec A upon 1 minus 1 upon sec A, right? Now you take sec A as a common in upper for numerator we take sec A as a common, so it becomes sec A plus 1 upon we have taken sec A as a minor, sec A as a LCM, so it becomes sec A minus 1. So sec A cancelled out, so you get sec A plus 1 upon sec A minus 1. That is equal to RHS. Get it? This is how I done. For solving this, there may be other options also. We can solve it with other options also. There is no problem at all, right? But this is the simplest one, so I did with this method, right? Okay. So come to question number 26, first part. Should I rub this? Question number 26, first part, that is 1 upon, can you read sin A, 1 upon sin A plus cos A? Oh, what is it written? What is written there? 1 upon sec A plus tan A. 1 upon sec A plus tan A. Then plus, okay, minus 1 upon, what thing? Cos A, oh my god, is equal to 1 upon cos A, uh, uh, sec A minus tan A. Oh, very good. Pretty good question it is. Oh my god. This is so LHS 1 upon sec A plus tan A, right, minus 1 upon cos A. Okay, very nice. So we can write it 1 upon sec A means 1 upon cos A plus tan A means sin A upon cos A, right, minus 1 upon cos A. Now again what we do, we take cos A as a common, so it becomes 1 plus sin A minus 1 upon cos A. Now this cos will go on the numerator, so we get uh, cos A upon 1 plus sin A, 1 plus sin A minus 1 upon cos A. Ready? Okay. So now what you do, you take cos A bracket 1 minus sin A as a LCM. So, oh sorry, 1 plus sin A is a LCM. So 1 plus sin A, 1 plus sin A is cancelled out. You get cos square A minus cos cancel. You get 1 plus sin A. Getting? I hope you understand. Okay. So what do you not understand? I hope 1 minus sin square A. Cos square A is 1 upon sin square A minus 1 plus sin A upon, right, upon, so here we can put square also, and this is cos A bracket 1 plus sin A. Now we will do डिफरेंस ऑफ टू स्क्वायर लगा देंगे 1 माइनस साइन ए इंटू 1 प्लस साइन ए, राइट, एंड वी गेट एंड माइनस 1 प्लस साइन ए, राइट, अपॉन cos a bracket 1 plus sin a. Getting? Now what you do? You take 1 plus sin a common from them. 1 plus sin a you take common from them. Then you get uh, 1 uh, 1 minus sin a minus 1 upon, oh my god, 1 minus, yeah, you take common 1, fine, okay, so that is we get, you know, so we get cos a bracket 1 plus sin a, right? This 1 plus sin a and 1 plus sin a is cancelled out, and this plus and minus is cancelled out, right? So what do you get? Now everything is correct. We get minus sin a upon cos a, right? Oh my god. This is, we can write minus 10a. This was LHS. Now you solve RHS, right? RHS when you solve, so in shortcut we'll do cos A minus, we have taken, you know, 1 upon cos A, sin A upon cos A, so it becomes 1 minus sin A upon cos A upon 1 minus sin A, right? So if we take cos A bracket 1 minus sin A, then what happens? Cos A cancel out, we get 1 minus sin A, right? And we get minus cancel out, we get cos square A. In the same process, we can take 1 minus sin A as a common, 1 minus sin A as a common, and it becomes left 1 minus 1 plus 1 plus sin A, right? Upon cos A bracket 1 minus sin A. This 1 minus sin A, 1 minus sin A cancelled out. When you open the bracket, again you get 1 minus 1 minus sin A upon cos A. And again this cancelled out and you get minus sin A upon cos A, which can be written as minus tan A. Right? So therefore, in this question, RHS LHS is equal to RHS is equal to minus tan A. Right? Hence true. Get it? I hope you understand this much. Okay.